Yes, hope you're well. Welcome to another video. Today we are working on this 2008 Mini Cooper. The customer's complaint is that the engine management light's on. As far as we're aware, there are no drivability issues with the vehicle. It drives straight, it's just the light's on. First thing we've done, yes, the engine warning light is on. So we've plugged our diagnostic machine in to read the fault codes off the management system. We have a look up here. We've got two codes. We have been playing with this before, so forget the heater control code. This P0137 O2 signal low bank 1 sensor 2 is the fault code that was in the system. I think our next step, or how I like to do it, is I like to read codes and I like to check live data. That way we're seeing what the ECU is seeing. So if the ECU is seeing a low voltage, hopefully we can pick something like that up in live data. So let's track back into find out some live data on it. So we're going to go into our data list and O2 control. So we've got voltages there listed. Now, in order for us to look at this properly, we're going to need the engine running. So I'm going to start the engine up. So let's start by looking at what the O2 sensor before the catalytic converter does. So once it warms, it's done its warm-up phase and it's got to a smooth sense of running, we should hopefully start to see this lambda sensor start to switch. So we'll just give that a sec. Well, don't make a liar of me. And there we go. So it's starting to switch now. And what you're going to see is every second or so that's going to switch up between 0.8 of a volt and probably about 0.2 of a volt, or 0.1 of a volt. It never reaches 1 volt, it never reaches 0 volts. That would either show a short circuit to ground or to positive. Looking at our sensor 2, so we've got a sensor before the catalytic converter and one after. So this is sensor 2 after the cat. That's just dead on 0 volts. So what this is showing is that the engine computer is actually seeing low voltage, which ties up with what our fault code was reading. So what we're going to do next, I think, is we're going to get underneath the vehicle and we're going to find that lambda sensor number 2, and we're going to have a look at that, check the integrity of the wire and do some tests actually on the sensor. Right, we're under the vehicle. I've just unplugged the sensor. You can see, hopefully there you can see it, we've got oil, engine oil, dripping out of the sensor on the harness side. Looking up, the reason that we find for that to happen is, let's move out of the way there, the reason that tends to occur is we've got a leak on the oil pressure switch, and the magnetic field created by the wiring harness draws the oil up the wiring harness, probably into the ECU and then out into the various different sensors kind of thing. So we're going to have a look at the oil pressure switch in a minute and see whether that is leaking. But what we want to do now is we want to check the integrity of the wiring harness. So is it a sensor that's failed and this is a byproduct, or is the wiring and everything all right from the engine computer to the engine ECU? So we are going to get a sensor simulator out and we're going to check our voltages and stuff using our Diagnostics sensor simulator. So let's have a look at that. Right. So we want to test and make sure that the wiring between the engine exhaust sensor and the engine computer is okay. So obviously we're getting the 0 volts on the thing. Now what you can actually see with this sensor now is currently unplugged, okay? So you've got 0.4 of a volt there. That's a bias voltage, so that's an engine check voltage from the ECU it uses to check the integrity of the wiring. So we do have a bias voltage there, but we want to check to make sure that the right signals and stuff are being transmitted from the sensor up to the engine computer. So we did a wiring diagram up. This is our wiring diagram for our lambda sensor. Pins 4 and 3 are our heater circuit. That heats the sensor up to bring it up to temperature so it gives a more accurate reading. And pins 1 and 2 are our sensor circuit. So we're going to use pins 1 and 2 on our wiring harness, and we're going to plug our sensor simulator in, which is this device here. And we're going to simulate a signal of a lambda sensor, and then we're going to look at the live data that we've got on our screen to see if the engine computer is seeing what we're transmitting up the lines. Cool. Right, so here's our lambda sensor. I've cleared sprayed it out with contact cleaner and cleaned as much of the grim oilness out of it as possible. Pins 1 and 2, as I described, are the two on the left here. We've got our sensor simulator probes. We're using our breakout kit of loveliness with our terminal kit, and we're going to fire that into pins 1 and 2 on there. Okay. What we've got on our device is we've got this set up as a peak voltage, or it's going to run between 0.2 and 0.8 of a volt every second. So if we look on, let's turn that round. Let's just turn that round that way. There we go. If we go back over to our scan tool and we look at live data again, what we can see there is we can see a lambda sensor value, and it's starting to sweep. You've got 0.8 volt there, you've got 0.2 there, and that's sweeping about every second kind of thing. So basically what that's shown us is that we've taken the lambda sensor out of the equation and we've put our simulator in its place. We can prove there that the wiring between there and the engine computer is okay. At this point, we're going to replace the lambda sensor because we know it's faulty. And we're going to replace our oil pressure switch as well because it appears to be leaking oil into the wiring harness. Now, it's very difficult, nearly impossible to get all the oil out of the harness, but if we can stop the leak, then hopefully we can prevent further occurrences or faults occurring due to that fault kind of thing. That was just a quick video of a nice little quick sensor diag. I hope you enjoyed the video. Please give us a like and subscribe. Check us out on our social media platforms as well, and have a great day. Right, as just an after one, we've just carried out the repairs to the vehicle, replaced the switch and the sensor. I thought he'd show you the result, because you always need to check the fix. So up here we've got our sensor before the cat that's bouncing nicely between say 0.2 and 0.89 of a volt. And then our sensor after the cat, we now have a voltage of 0.83 of a volt because they run on a 1 volt scale, and it's nice and smooth, showing that the actual cat is working and it's doing a job kind of thing. So we're happy based off that. So we've diagnosed it, we've carried out the repair, and we've also checked the repair is good. So we're happy the customer can have their car back with no warning lights on and be happy they can carry on driving it. Take care.